Mangrove forests are amongst the planet's most powerful carbon sinks. They capture and store blue carbon. Blue carbon refers to the carbon captured and stored by coastal and marine ecosystems, mainly mangroves, seagrass beds, and salt marshes. These ecosystems absorb carbon dioxide, CO2, through photosynthesis and store it in their biomass and soils for hundreds or even thousands of years. Despite their importance, mangroves are disappearing rapidly. Accurate monitoring is critical for the conservation and for nations reporting on the global carbon frameworks. Red mangroves are very distinctive in their appearance because they have prop roots or stilt roots. Black mangroves, on the other hand, look like a regular tree in that the trunk goes straight into the ground. However, their roots send up long finger-like structures called pneumatophores, so they're also very easy to recognize. White mangroves are similar to black mangroves in that they look like a regular tree, they go straight into the ground. However, the bark is actually much lighter. Black mangroves have a much darker trunk and bark. You could also tell based upon their leaf structure. Red mangrove leaves are slightly rounded, whereas black mangroves are much more oblongated, and white mangroves are very rounded, and they're also a bit lighter color, a little bit whiter. But most of the time, because of where we are on the ground, we can tell based upon the root and trunk structure. Terrestrial laser scanning, or TLS, uses light detection and ranging, LiDAR, technology to create detailed and accurate three-dimensional models of mangrove trees. In this video, we will be guiding you through a step-by-step pre-fieldwork preparation, field measurements, and post-processing. Before scanning, the team ventures out into the plot area to select an appropriate tree. Once the tree is selected, the site is prepared by cleaning the debris. These steps ensure accurate data capture. One of the conditions which has to be met is that the mangrove tree that we are going to be scanning should not be intertwined or maybe lying against another tree, because this creates problems for the scanner to capture the data in sufficient detail. For example, if the trees are intertwined, one tree is going to be blocking the scanner points from the focus tree. So it should really be a separate individual tree that you're selecting. Additionally, we have to be able to see the top of the canopy from at least 3 angles at roughly 120 degrees. So the way that we do the scanning, there are 2 rings of scan. The outer ring, which is meant to focus on the top of the tree, get the canopy and branches characterization, and an inner ring, which focuses on the roots in order to capture them in great detail. So our outer ring has to have 3 scans, or at least 3 scans, at 120 degree angles. That's so that you get complete characterization of the canopy. It could definitely be more, so it could be 4 or 5 scans, and it usually ends up being more scans because there are only certain gaps in the canopy that you can capture. But the scans should not be clustered, for example, on one side of the tree. If you do 3 scans on this side and no scans from that side, you're not going to get anything on the other side of the tree. So it has to be encompassing the tree from all directions. So from up here, you get a very good perspective of where you have very clear sight lines. For example, I can see straight down there, there are no trees in the way, so you can get a good view of the canopy from that direction. And we can put the targets in a breadcrumb fashion, which we will demonstrate just now, to link the outer targets to the inner targets. We also have a very good clear line of sight going down in that direction. So that's less than 120 degrees, or roughly 120 degrees. In these directions, it's much denser, so we have to probably do 4 scans for this tree for the outer ring. 1 probably down there, and 1 over there. So we can say that this is an appropriate tree to scan. So now what we will do is set up the targets for the outer ring. Now that we have our tree that we're going to be scanning, our focus tree, we need to put up what we call the wall, which is just a blue or very visible tarpaulin in the mangroves. The reason we set up this wall is so that we have a landmark or a very easily recognizable point of reference. When we get to the software stages, you'll see this. Usually the scanner can automatically combine the scans together. However, there are certain circumstances where it can't. So we have to manually combine it. So we use the wall as a visual point of reference that's easily recognizable to link scans together. So we have to choose a location where the wall will not obstruct our scans, but also where it will be visible from every single scan. So it should be in relatively close proximity to our focus tree, which is the tree right behind me, and it shouldn't obstruct the scan. So we know we're going to be doing the inner ring of scans right somewhere around here. So we should probably put our wall just beyond it. For example, between those trees over there, we'll place the wall there. So therefore, we know our scans from over there, we'll be able to see it. Our scans from over there, we'll be able to see it. And obviously our inner ring scans will be able to see the wall. So we'll now put up the wall over there. So we also have to take some measurements of the individual tree. These can serve effectively as validation measurements. So best thing to do is to use some flagging tape, some brightly colored flagging tape, and mark it or place it on the tree where you're actually measuring the dBH. This flagging tape will actually be picked up in the scans. So therefore you're able to know exactly the location where you conducted the measurement. So for red mangroves, you have to measure the diameter at breast height just above the height of the tallest prop root. So in this case, it would be right here. See, so this is a diameter at breast height tape. If you don't have one, you can simply use a seamstress tape and take the circumference and calculate the diameter. So this tree has a diameter of 13.75. And we put the flagging tape exactly where we took the diameter at breast height. So therefore, we'll be able to cross-reference this with the scan. We also often take the measurements, some measurements of the diameters of roots. Again, this can be, we use these as validation measures in the scanner. So I'm going to do this root over here. So this root has a diameter of 5.2 centimeters. And you can do multiple locations, and you can just mark them with the flagging tape and take the measurements. So now that we have selected our focus tree and we've selected the locations where we generally know our outer ring scans are going to go, we have to place the targets. Now, it's important to remember that scans are automatically linked together or manually linked together when you can see at least 3 coincident targets between 2 different scans. So you must bear that in mind when you're placing your targets and you're selecting the exact locations where you're going to be conducting scans. So we're going to place our targets for the scan that's off in that direction, for the first outer ring location. In order to get the outer ring scans to link to the inner ring scans, we have to set up the targets in a form of breadcrumbs. So you'd put some targets close to the tree, moving out, sort of a breadcrumb fashion. going out towards the direction where you have your outer ring scans. So you can see that we've clearly marked our focus tree. It's the one with the blue flagging tape. And we're going to be placing some targets back there, but we're going to place some targets over here for now for the outer ring scans. We know our outer ring scan is generally going to be out there, so we don't put a target directly in front of the tree, put it off a little bit to the side. So this is the location of our first outer ring scan. You can see that we've set up the targets going back in sort of a breadcrumb effect towards our focus tree. You can see it in the back there with the blue flagging tape. Also, you can see the wall is very clearly visible from this location. So we know that this is a good scan location. Also, if you look up at the canopy of the tree, you can see it's relatively clear. You can see most of the tree. There's no other huge parts of other trees blocking our focus tree canopy. That's a very important consideration because these outer ring scans are meant to really focus on capturing the canopy of the tree. We also have to take the measurement of the height of the tree, and we do so using a vertex hypsometer. For the MRV project, vertex hypsometers were provided, a different model to this, but the basics are the same. So now that we've placed our outer ring targets going down at our 4 outer ring scanning locations, we place the targets for the root or inner ring scans which we're going to be conducting. How we would capture the roots is we would count the number of major root systems. For example, this is a major root system here. So there's 1, 2, well, this is 3, 4, 5, 6. So what we would do is, so you're doing n plus 1 situation. We have n is the number of major root systems, so we will do n plus 1. We do 7 scans, well, at least 7 scans for the roots. We do this n plus 1 so that we can get characterization of the roots from both directions. So we have like 1 here, so you'll get the scans picked up on this side of the roots. We do another 1 here, you get it from this side of the roots. You want to do that so that there's no occlusions. Also, not uncommon for red mangroves is that you'll have a very long root going off. You'll have to probably do a medium ring scan to capture those long root situations. This is an example here. It's kind of going off in this direction, but a scan that's located right there will be able to capture this no problem. It's only if the roots are going a very extended distance away from the tree would you likely have to do some scans down there. And likewise, you'll need to place targets over there. For this tree, we can just put targets around here. So if you recall, we have some targets from our outer ring scan down there. So we have to make sure that the scans over there can see at least 3 coincident targets to a scan that will be close in the inner ring. What is particularly useful is to put targets higher up in the trees, because we are able to, the scanner is able to see over the roots and capture the targets very well. So we're going to actually put some targets up in this tree here. So you see from up here, we can very clearly see where our outer ring scan will be down there, and you can clearly see these targets up here. So usually we just use plastic cable ties and attach them to secure the target. So you see, we orient the target so that it'll be clearly visible from down there and from over here. So potentially a scan that's all the way over there will be able to link to a scan that's all the way down there. But I'm actually going to put 2 targets on this tree. I'm going to put another one on this tree that's high up. It's important that the targets are very securely attached, because once you start scanning, the targets cannot move at all. So you have to make sure that no wind will move it out of the way, or that it cannot move, fall in any way. Now we can proceed with putting the targets around the roots of the tree. It's important to make sure the targets are well in the ground so they don't move. Also, it's important that you don't, once you start scanning, you don't step near a target. For example, if you step near this target, just compression of the soil will move it. So you don't want any targets to move once you start scanning. So always give the targets a wide berth. Stay at least, once they're placed, stay at least half a meter or meter away from them. First of all, the scanner has a number of lenses as well as the laser shield and mirrors. You should never touch those surfaces with your finger or let any other foreign object come into contact with those surfaces, because even the oils on your fingerprints can result in refraction processes which impact the laser's ability to collect accurate readings. So you should, if you do happen to come in contact with these surfaces, you should use a very special microfiber cloth which is provided with the scanner to clean these surfaces, and the Leica BLK316 manual actually outlines the process of cleaning these surfaces. So refer to that for this process. So when you take out the scanner, the first thing you should do is set up the tripod. Now the tripod has a number of different segments. You should unscrew each individual segment and extend the leg, but then push them back against each other so that you make sure that the segments are actually screwed and locked in correctly. We do this because you don't want the scanner to fall over into the mangrove water, which will probably ruin the scanner. So you do this for every single individual segment. Then you take out the vertical pole onto which the scanner is actually mounted. You compress the two buttons at the top, and this retracts 3 balls which are on the top base of the pole. We then put the pole directly into the tripod and tighten the base below, and again you push down on the vertical pole and the tripod to make sure that it is secured, and then your scanner is set up. It's advisable that you use the cover to shade the scanner until you actually need to use it. We do this so that no foreign objects can come into impact with the lenses or the laser shield. Or if, well, you really shouldn't be scanning in rain, but if there's a light drizzle coming, you'd want to protect the scanner from that. When transporting the scanner in the swamp, it's best to keep the shield on. This is to protect it, to make sure that there's no splashes of water or mud that get onto the lenses or the laser shield. Also, always hold this part. Don't just hold the tripod, because the tripod is just technically attached to this, but this is actually more secure, holding the scanner. You could close the scanner legs if you like. Depends how agile you are. I just usually close them in, hold it like this, and walk. So we can go to the outer ring scan location now. So we're now ready to do our first outer ring scan. So we set up our scanner, make sure that it's secure. The scanner does not have to be perfectly level. There is a sensor in it that it will level itself or detect its angle, so it doesn't need to be absolutely flat. When you turn on the scanner, you can just hold down the on button for 3 seconds. A flashing yellow light means it's doing something. So in this case, it's starting up. Once it's turned solid green, it means that it's ready to go. So there you go. It's solid green, so it means it's ready to start scanning. Now, before we start scanning, we have some checks to do. First of all, from this location, we want to make sure that the scanner can actually see every single center point of the target. So the best way to do that is you put your eye by the scanning emitter, which is right here. So you put our eye right here and we look at the targets. So we see down there, this route is blocking several of those targets. So this location is not that great. So we're going to shift the location to a little bit that way. So we should get around this route, which is blocking the view of those targets. So just by moving the scanner 30 centimeters this way, we're now avoiding this route. So we have a clear line of sight to all of these targets. However, that target way down there is actually being blocked by that stump. So I'm just going to go and move that stump, because the more targets that the scanner could see, the better. Do a little bit of a double check. We can see now with that stump gone, the scanner has a clear line of sight to that target. As we have a very clear line of sight to our targets, we're ready to scan. But the field team is best that they are not in the scanning range or not direct visibility. So first of all, you can never be between the scanner and the targets. If you're here and the scanner is scanning and you're in the way, it's not going to see the targets. So you cannot ever be between the targets and the scanner. Also, the scanner has a range of 50 meters, so it's going to scan all over there. We're not going to be using that for data, but it's good to keep it relatively clean looking. So like as I'm in orange, if I stand there, all those points will end up being orange. So before you start scanning, it's good to find a good hiding location. So for example, those mangroves across there, I'm just gonna, when I click the scanner to start, I'm gonna run and hide behind those trees. You also have to stay in a position where you can observe the scanner. So you have to choose that hiding spot before you start scanning. When you press the start scan button, which is also the power button, you have approximately 10 to 30 seconds till it starts scanning. You can set that previous to coming out in the field through the software. So when I press this button, it'll start scanning, and I'm going to run and hide behind the tree. As you see, it's blinking yellow. It's doing something. As you can see, it's preparing to scan. So you basically shouldn't be interrupting it in any way. The scanner does either a full or a half turn rotation. That is where it actually orients itself using an inertial measurement unit and a gyroscope to determine what is flat. So it's basically leveling itself based upon gravity. So you can see here the scanner has turned back to a solid green and stopped moving. So that indicates it's completed its scan and could potentially scan again. Now while it is scanning, you have to be looking up at the focus tree to watch to see if there's any wind. If there was any wind and you see the tree moving during the scan, you should rerun the scan. To rerun the scan, leave the scan in the exact same position, just press the start scan button and run and hide, and it will conduct another scan. And you just make sure that the tree is not moving while you're scanning. Our outer ring scan was over there, and you can see our focus tree is right there. Each scan has to be able to see at least 3 coincident targets between 2 scans in order for them to be combined together. So if we were to just do an outer ring scan and an inner ring scan, we may not be able to link the scans that easily. So therefore we do a mid-ring scan. So it's roughly midway between the outer ring scan and the inner ring scans. So if we set up here, we know what targets we could see from our outer ring scan. We could see all of these targets and the 2 up in the tree. And so we're going to do another scan here. So I put the target here, the scanner here, and I see, I could see all of those targets and all of these targets. So we may think we're good. We are good, but this target here, the angle between the scanner and the target is very oblique. it should be more like ideally not more than 45-degree angle. So therefore we move the scanner just a little bit this way, and now from this location we have a much more direct view of this target. So we know that it will be captured. Oblique angles are not easily captured by the scanner. So this mid-ring location is really good because we could see all these targets, and we can importantly see the targets that will form the inner ring scans. All those targets over there and the ones up in the tree. We still put our eye and check out the locations there. And from this location I could actually see the center point of those two targets over there. So it's very important to do your checks. So from this location we would do an inner ring, mid-ring scan. So now we're going to do the inner ring scans. So this is our focus tree. See, we're very close to the roots. Something to remember is that the scanner cannot pick up data within 50 centimeters. So you have to be at least 50 centimeters away from your tree of interest or your focus tree. We are very close to these, but these are irrelevant because they're not close, they're not our focus tree. But our focus tree, we are more than 50 centimeters away from all of the elements, the roots, branches, and trunks. And so from this position, you could see, you put your eye by the scanner location, you can see it's very clear. You can see all of these targets. Also the angles to the scanner, to the targets, are not oblique. They're quite direct. So it's not too much, it's a good quality scan. Also, we could see our targets that are higher up there are very clearly visible. And we could see all of our targets from our mid-ring and outer ring scans. So we could be fairly confident that these scans can be automatically combined, and if it cannot be automatically combined, we can manually combine them. So we're ready to scan our first scan of the inner ring. I chose my hiding spot. I'm going to run and hide behind that tree over there. So we're ready to scan. Take off the shield and just press the start scan button. Our first inner ring scan is complete, and this would have picked up the roots for this major root system from this side. So now we have to pick it up from the other side. So this is where we start doing the scans in between the major root systems. You would get the other side of the roots. Again, recall that you cannot be closer than 50 centimeters. So this is another good location as we can capture all of the interior part of the roots. So we can start scanning. At dawn, when the winds are calm, the scanner collects data from multiple positions around the tree. Using Cyclone Register 360, the scans are merged into a high-resolution point cloud. This allows scientists to measure the biomass without cutting a single tree. When you start Cyclone Register 360 and you click on all projects, you will see all the projects which you have previously engaged in. Start a new project, click on Create New Project and enter an identification name, and then click OK. This opens a blank project. You should select background image of none, then click on BLK 360. I have the BLK 360 G1, so that's why I have selected the G1. You then click on Discover and Connect Device. You now have the options to set the BLK capture settings. The scan density should always be set to high. You can set the image to either LDR or HDR. And you can also sync the time with your local computer setting. it gives an indicator of the battery level also. The lower part of the panel has the date and time of every single scan that is still stored on the scanner. So you can select the scans that you collected in the field. Then click on Add to Project. On the bottom left-hand panel in a table of contents style, you still have all these files which are stored on the scanner, but your scans from the individual project that you selected are highlighted with ticks. Ensure that Auto Cloud is not selected. Only Auto Black and White Target should be selected. And then you click Import. This will import all of the scans and continue to the next step, which is using targets matching to link these scans together. This can take some time depending upon the number of scans which you have to combine together. When it is done, it will say successfully imported all the given scans. Now this displays all the scans which have been combined and the scans which may not have been combined. So these scans are individual scans which were not able to be combined. However, this scan on the top left has been able to successfully combine two scans together. So that's why this is bundle number 1. So this is the first bundle, while the other scans are individual scans which we will have to combine manually later. So you can see here this is called bundle number 4. Bundle number 4 consists of 2 individual scans, scan or setup 64 and setup 66. And this shows you the targets that Cyclone has identified and numbered. So we are in sitemap view currently, and this is where you see all of the bundles as well as all of the unlinked scans. If we click on an individual bundle, such as this one, and then we click Setup Cloud, we will see the points and the picture from this one individual scan in this bundle. So we're not looking at a combined bundle at this point. We're looking at one individual scan. There you could see the wall. However, if we now click on sitemap, revert back to our previous view where we could see all of our scans. And if we select Bundle Cloud, now we will see the combined points of these 2 scans, or however many scans you have in this individual bundle. So we can see the setup 66 and the other setup or scan 64, which have been combined together. You can see that it has automatically recognized targets. That's when targets have a red or green crosses through them. And now we revert back to sitemap. If we click on this individual scan, setup 65, and we go to setup cloud, again, we are seeing this scan, this individual scan, setup 65, from the perspective of the scanner and the image. But we can switch to point cloud view by clicking on the orbital option in the controls on the left, top left. So now we can scan around within this view. And then we revert back to the sitemap. It's advisable to explore some of your data before you proceed to manually scan combination. We use the wall to do manual scan combination. Sometimes it's difficult to see the wall because of all the points surrounding it. Therefore, we may need to delete some points. So here we go, we identify our location of our wall, and we're going to clear some of the points out from around the wall to make it more visible, being careful not to delete points from our focus tree or target areas. So we select bundle, and then we will select the polygon option of here, and draw a polygon around the area that we would like points deleted from. So everything in this area will be deleted. Ensure that Edit Cloud Points is selected and say delete inside or outside. In this case, we want to delete inside of this polygon, which is all the highlighted points. So you'll see that all the points in this area and the area extending straight through behind our selected areas are now deleted. So they're not completely gone. They are still stored in the actual data sets. However, visually, they have been removed. A number of points towards the top right have been removed. But say we made a mistake and we accidentally deleted some areas which we need to come back. We can highlight the area that we want the points restored in and then say restore inside. Because this entire area is being restored, it'll restore all the points in the bundle, which you can see now to the top right, all the points which were previously not there because we had deleted them are present. You can also delete and restore points from individual scans. And you should always select the both options if you are deleting or restoring points. If there are a large number of points to be deleted or restored, it can take quite some time for this to happen. But you can see all the points around the wall or behind the wall where we had previously deleted and are present now since we restored them. When we need to manually combine the scans, we use the wall as a easily identifiable landmark. We first have to locate the wall in our point cloud. So here we can see the wall, the blue tarpaulin, and we note the orientation of the wall from the top right to bottom left. We then drag another scan which we need to combine closer to our bundle which we are going to combine this scan with. And we have to locate the wall in this scan. So here we see the wall. It's moving from a bottom right to a top left orientation. So we need to reorient these scans to be the same. Hold down the shift button and then the left mouse button, and then we can drag out and change the orientation of this scan. So we see now the wall is oriented better to our wall in the previous bundled scan here. However, it's not exactly the same angle. We need to adjust our scan a little bit more. So we change the angle a little bit more so it will be more similar to our first scan. Then we drag the wall over the other wall. And they examine how close the fit is. The fit does not have to be perfect. It is simply getting it roughly into the correct position. And here we go. We see our wall and they overlap fairly well. These dashed lines illustrate the possible links. So now we choose the two scans that have the closest distance between them and click on split view. This gives us the view from both scans perspectives. We must first lock the view, which we select with the paperclip, and we look at the various targets. And now we see these targets visibly line up fairly well. So we have positioned our two scans relatively well. So we can see now the scan using the orbit function, and we can examine the views in both scan panels. We have to select manually the center point of each scan. To be safe, we put that center point of each scan in front of some black no data space. We do this in case we accidentally click a point behind our target. It will register that point, not the point in the center part of our target. So that's why we put it the center part of the target in front of some black no data space. We do it the similar process now for the right panel. So we find the target and we put the center part of that target in front of some no data space. And then we select the center point of that target. As you can see, it can be a challenging process to get this correct. It is also important that you view the target from a very direct angle. It should not be very oblique. And there we have selected coincident center point targets in both the left and right scan panels. We have to do this at least 3 times for various targets in order for the scans to be possibly linked. So here again, we put the center point of the target in front of black no data space in the left panel, and we do the same in the right panel. Be very careful. Once you have selected your points, your center points, immediately switch back to orbit mode. If you are in point selection mode and you select anywhere by accident, it will register a new point and you have to start over this process. So as soon as you've selected your center point, switch back to orbit mode. So we've done 2 targets in both the left and the right panel, and we have to do at least 1 more target to have the option to link the scans together. So I made a mistake there, and you can see the point was selected far behind. So I had to start the process over, and I cleared the selected points, and now I've restarted the point selection. So that is coincident target 1. This is coincident target 2. And now coincident targets 3. Although a minimum of 3 coincident points are required, you should do as many as possible because it will increase the strength of your scan combination and reduce your positional error in the scan combination. So that is center point targets 1, 2, and 3. Now we can have the option to create a link. So this is trying to combine the scans together. So the left panel scans and the right panel scans. As we'll see, the output of this is not a particularly strong combination. It says the link does not seem viable. However, we say yes, we want to keep it. When we do this, it will move the scans on the right to align with the scans on the left. Now, although it's not a very good combination, it is closer than what it was before. So what we will do is accept this relatively poor scan combination and redo the process. So the relatively poor scan combination is identified by a blue line. So we're going to go back into split view and we're going to redo the process. Now the scans are more accurately aligned now because we've already gone through this process once. So you can see the scans are much closer together already. So we're going to repeat the process of selecting the center points of the targets in the left panel and the right panel to combine the scans. So when we do this, we see a much better result. We see most of the points are to the left of that line. So we say, Okay, and the link is successfully added. So we have successfully combined this scan together, and you can see that it's now a green line, which is a good scan combination error assessment. We can also use the position of the targets to help align our scans. So once we have correctly oriented our walls to each other, we can also then use the location of targets as an extra set of landmarks. So we see we've already oriented our scans together, and we'll look at the positions of these targets and overlay them. So we drag our second scan closer to our bundle of scans in the bottom left. So you see we pull our scan closer, and then we ensure that the targets line up. You can see here, these two targets here are aligned with these other two targets there. And therefore, our scans, this new scan that we're trying to combine with the other bundle of scans, should be good. So we select our two closest scans in that link and click split view. And then we lock the views together or sync the views together. Now if we look at our panel on the left and the panel on the right, we will see that they are oriented and located pretty well. These targets are all aligned. So we see it from the same perspective and roughly in the same correct locations. So we know that we have successfully positioned the scan that we need to combine fairly well. We now need to do the selection of the center points of the targets. So in orbit view, we can zoom in, position the center point of the target in front of black no data space and select the center point. And repeat the process for our scan which we're trying to combine in the right panel. So that is one center point pair of targets completed. Remember, we need to do at least 3, ideally more, provided we have coincident targets which we can combine. So that is center point target pair 2, and this is now center point target pair 3. Now this target in the bottom right, the center is not visible because a branch was in the way, so we cannot use that target. This target, the right hand side is a little bit obscured, but the center is visible. So if you have no other choice, you could use that. This target has a lot of noise, so it is not a good idea to use this target. So we can look around to see if there are any other targets which we could potentially use to link together. So here we have 3 pairs of targets, and so we now can say create link. The link that we're creating here is not a very strong one, as we will see shortly. The graph that will be displayed will have most of the points to the right of the green line. This is indicating a relatively poor level of scan combination accuracy. We want most of our points to be the left of the green line. However, we will accept it because it will position our scan. So we can see most of the points are to the right of the green line. So we still accept it, and then we will redo this scan combination process. However, because we've already gone through this process once already, it will be more aligned, so it'll be an easier process, as well as it'll increase the accuracy. So you'll see the link added is red. It's a poor quality or poor level of accuracy. So we'll go back into split view and redo the process we just did. But since we've already done it before, the alignment is considerably better. You can see that between the left and right panels, things are very highly aligned. But we want to improve this process. So we will do so by selecting again the center points of at least 3 pairs of targets. So that is pair number 1. This is pair number 2. And this is pair number 3. And we update the link. And this produces a better output. You'll see most of the points are now to the left of the green line. So right now we can't see the link because sometimes the program malfunctions, but the link is there. When this happens, you need to just close and restart Cyclone. Here I just restarted Cyclone and the link is displayed. You see the link is blue, which is a good, strong link. So we've now combined 4 scans together. We still have remaining 3 scans to be combined. After we've finished combining all of our scans, we can see them here. Our focus tree is in the center of these scans. However, you can see we have a lot of extraneous data points which we cannot really use. So we would like to remove most of these so we can make the exported file at the end smaller. So we just want the data that's in the focus area here within our scans. So we can start to delete points and clean much of this point cloud. So we select the bundle in the table of contents, and then we select polygonal option, and we draw a polygon around the points that we would like to keep. So the highlighted points will be kept, and we select edit cloud points and select delete outside. So all the points outside of our polygon that we just created will be deleted. Remember, these points aren't actually permanently deleted. They are simply removed from our visual field of view, as well as this cloud-to-cloud datasets. But they are there and can be restored if needed. So you can see we've drastically reduced our points. However, we can still continue to whittle down the point cloud until we have just our focus tree or focus trees left in our point cloud. So we don't need anything on the left hand side here of these points. So we're going to delete these points. All of the points to the left of this line are completely beyond our focus area, so we will delete these also. So we keep doing this until we're left with just our focus tree area and our targets. So this is our focus tree area. I was a bit hesitant to delete the points in the canopy. These can be cleaned later in Cloud Compare. Once we have selected a bundle, we can click Optimize Bundle and then move on to the next step, which is finalize. So this gives us some error assessments or accuracy assessments. So you have to click accept twice. So first accept, which will take a picture of the scan combination in order to put it on the page of the report, and click accept a second time. This is the location to which the accuracy assessment report will be generated. This should be kept for reference in the future. And we would like to export the actual point cloud. I usually export it as PTS format. You can also select LAS or PTX and say save. You can then click publish, and this creates the report and exports the PTS file. This export process can take a while if it is a rather large number of points. Once it is finished, you will see this notification, and you can look into the location that you saved your PTS file, and you'll see it's been produced. Notice it's a relatively large file. This is approximately 5 gigabytes. This can then be imported into Cloud Compare for further editing. TLS data feeds directly into monitoring, reporting and verification systems, improving the accuracy in national carbon inventories. By transforming how we measure mangroves, TLS empowers conservation, restoration and sustainable management, capturing the unseen one laser scan at a time.